We have done quite a bit of ray tracing. Now we are on to the last one. This is ray tracing. We are going to look at a concave mirror with our object inside the focal length. So I'm going to pause and grab a mirror. Alright, I have a focal length of 15 centimeters, and I would like to place my object at the 10 centimeter mark. So here's my 10 centimeter mark. I know from having done this before that it's going to be beneficial for me to use a small object. So my D object is going to be 10 centimeters, which puts me inside my focal length, and my height object is going to be 2 centimeters. And we'll see where that takes us. So here we go. Ray 1 is going to go parallel to my axis and then through the focal point. So from my object, I'm going to go parallel to the axis until I hit my mirror, and then through the focal point. Which looks like that. There is my ray 1. Ray 2 is going to go through F prime, and again for a mirror, F prime and F are the same, and then parallel. So I'm going to go through F prime, which is a line that contains that, but then I'm going to have to hit my mirror. So I'm just going to do this now. Go through F prime, hit my mirror, which looks like it's going to come out there, and then go parallel out. Rays 1 and 2 are not going to cross each other, so I need to trace these things backwards. Ray 1 prime, I'm taking the reflected ray, which is here, and seeing where does it come from. So where it comes from is going to be something like this. And that's sort of my 1 prime, and my 2 prime. I'm going to take, again, the reflected ray, and I'm going to find where does it come from. And it comes from here. There's my 2 prime. 1 prime and 2 prime cross at this location. So there is my image with my object being back here. I can get a couple of pieces of information off of this. My image distance looks like it's going to be 30 centimeters. And it's behind the mirror, so it's negative. I do want to point out, I am counting this off of the surface. So I'm counting this off of here. I'm not counting this off this back edge, right? This mirror works just as well if it extends back here. So my image distance is negative 30 centimeters. My image height is 1, 2, 3, 4, 5, 6 centimeters, and it is positive because I am upright, and now I'm going to get rid of the grid. It's really helpful for the pictures, but it also adds a lot of busyness to the pictures. So here we go, my magnification. I'm going to say HI over HO. Let's see what that looks like. I've got 6 centimeters over 2 centimeters. I'm getting a magnification of positive 3. I want to check it against the other form. DI over DO with a minus sign is negative. Is still a positive 3. which checks out. It's a good way to see, did I do this well? This is ray tracing for a concave mirror with the image being formed, with the object being placed inside the focal length. In the lenses videos, I gave you at the end some kind of a summary. I want to give you a summary on concave mirrors. I already gave a summary on convex mirrors. So for a concave mirror, I have a couple of different situations. I can be inside the focal length, meaning my object distance is less than my focal length. If I'm inside, I will make a virtual upright image as you have seen, and it will be enlarged always. When we get to the lens equation, you'll see why it has to be always. If I'm at my focal length, so D object is equal to F, then I make no image. And then I've got outside. If I am outside of my focal length, I will always make an inverted image that's real. But the size of the image depends on just where I am. If my object distance is outside my focal length, but less than double my focal length, then this will be an enlarged image. If my object distance is exactly equal to double my focal length, I'm going to get the same size, which means I will end up with a magnification of -1 because I am inverted. And if my object distance is greater than double the focal length, then this will be reduced. That's kind of my summary statement on the images formed by concave mirrors.